Alright guys, so now that we've talked about the graphs of exponential and logarithmic functions, we're going to talk about the properties of logarithmic functions. So when you're doing the properties of logarithmic functions, there's some rules you need to follow. Alright, so we know the logarithms of bases other than 10 or e, common natural logs, do not have specific evaluation keys on our calculators. So in order to evaluate these logarithms with the calculator, we must convert the base to either base 10 or base e. We do so with the change of base formula. So if you have a log that is not base 10 or the common base or natural log base, what you're going to do is the change of base formula. So change of base formula looks like this. Log of base a of x equals log of base b of x over log base b of a. Now when we do this, we change the b to a 10. So a, for example, if I have log base 5 of 42, we can't type that into our calculator. So what we do is we convert it to something we can type into our calculator. We convert it to log base 42 over log, or not base 42, base 10 of 42, base 10 of 5. And that's what you just type into your calculator. You would type in log 42 divided by log of 5. Or you can also use natural log. That's the same setup, and they're both on your calculator. So when you do this, I would type it in, and you should get like 2.322, somewhere around there. So go ahead and try B. If I have log base 2 of 21, how can I rewrite it? And then how can I solve it? So again, you're just going to type it into your calculator, and you're going to need a calculator for this whole lesson, so you might as well get one out. Hopefully you got 4.392. So that's if it's not base 10, we use the change of base formula in order to solve it. All right, so that's kind of the first one. Then we get into the essential properties of logs. So log base a of 1 equals 0. The natural log of 1 equals 0 as well. Log base a of a raised to the n power equals n. The natural log of e, common base to the n power equals n. If you are multiplying, you split it up with a plus sign. If you are dividing, you split it up with a minus sign. If there's an exponent, you can put it out front to rewrite the problem. So now we're going to look at how these properties are used. So it says use the properties of logs to expand the expression as a sum, difference, and or constant multiple of logarithms. So a, if I have log base 4 of 5x and I say split it up, what I want you to do here is think about it. We're taking 5 times x. So we're going to split it up into log base 4 of 5 plus log base 4 of x. So you can split it up by changing it to a multiplication problem, or multiplication to an addition problem. So b, if you have an exponent, in order to rewrite that, you put the exponent out front. So I would say 3 log base 4 of x. And these just make the problems easier to solve. C, I have log base 5 of 5 over x. This is going to be a subtraction problem. Whatever is being divided by on the bottom is what you're going to subtract. So I would say log base 5 of 5 minus log base 5 of x. Now this is also a property. Log base 5 of 5, if they're the same, that's just going to be a 1. So I'm going to rewrite it as 1 minus log base 5 of x. All right, D, it's the natural log of x to the 4th square root of y over z to the 5th. So here they get a little bit harder because we're going to combine some rules. All right, so if I wanted to split this up, let's rewrite this first. So that's 4 ln of x, natural log, because the exponent goes out front, the x goes in front and as the part of the base. So then I'm going to add it because I'm multiplying by the natural log of the square root of y on top. Minus, because we're dividing by, the natural log of z. Now you need to get in the habit of rewriting this as an exponent. So just as a reminder, the 1/2 power is the same as the square root of y. So I'm going to put that 1/2 out front, and I'm going to say minus 5 natural log of z. E, I'm going to do up here, the natural log of x, y, z to the second. We're going to split it up. This is multiplication, so we're just going to write them all as addition. Notice the z has an exponent, so I'm going to put that 2 in front of the natural log of z. And then last one is f log base 2 of 8x to the second plus 64x plus 128. So on this one, you kind of have to do some factoring. So we're going to split it up here. 8 goes into all of these, so we're going to divide all of those by 8. So what we're going to do is we're going to say log base 2 of 8, because that's what's going to go on the outside. X squared plus 8x plus 16 is what's left over. Now, this is a multiplication thing, so we're going to rewrite it as log base 2 of 8 plus log base 2 of x squared plus 8x plus 16. Now, x squared plus 8x plus 16 can be factored into x plus 4 squared. So I'm going to say log base 2 of 8 plus log base 2 of x plus 4 squared. Now, log base 2 of 8, I got to think 2 to the what power gives me 8? Well, that would be 3. So this is going to turn into a 3 plus log base 2 of x plus 4 squared. And then lastly, I need to simplify this by rewriting it. If it has an exponent, we put it out front. So we'd say 2 log base 2 of x plus 4. And there are problems just like this one on the HOC, so you need to know how to do that. So our final answer is going to be 3 plus 2 log base 2 of x plus 4. All right, so now we're going to take it, and they're going to give us something that is already expanded, and we're going to condense it. So A right here, notice they're adding, so that's going to be a multiplication problem. So I'm going to say ln of 3x. We're going to take it, and we're going to turn it into a multiplication because it was addition. B, we're going to condense this one. All right, they both have log base 4, but this is subtraction, so that means we're going to divide. So the first one goes on top, and I'm dividing by whatever is being subtracted. C, don't forget if it has a number out front, that's going to be an exponent. So I'm going to say log base 2 of x squared plus log base 2 of, what would that be, 16? We're going to rewrite this as log base 2 of 2. I've done the wrong problem there. All right. So when I add those, I'm going to say log base 2 of 2x squared, because you're multiplying when you add. D, it's subtraction, but notice the x plus 1 should be in parentheses. There's a 3 out front, so I'm going to be doing division. The x goes on top. X plus 1 to the third power is what goes on bottom. E, there's subtraction and multiplication. All right, so no matter what, if you're adding, it's going to go on top. So I'm going to say log base 4 of x z to the third, because the z to the third is an addition one, so it's going to go on top. I'm dividing by y squared, because there's a 2 out front, so the exponent becomes a 2. And then lastly, F, I have log base 4 of x squared plus 10x plus 24 over x plus 6. We're going to factor the top into x plus 6, x plus 4 over x plus 6. Notice your x plus 6's are going to cancel, so your final answer is going to be log base 4 of x plus 4. And that is condensing it if they gave us something that's already been expanded. So then I just have some practice problems for you guys to do. All right, so 1, 2, and then it says B and B. I want you to try all 4 of them in the expand and the condense part. So number 1 up here, we're expanding. So I should have log, there's a 3 out front of x, plus log of y, plus 2 log of z. So hopefully that's what you got for the first one. Number 2, all right, I'm going to say log base 3 of 27 plus 4 log base 3 of x. 3 to the what power gives me 27? Well, that would be 3. So this would be 3 plus 4 log base 3 of x for number 2. B, we're doing division. However, the top is going to be multiplication, so I'm going to add, and I'm going to subtract by that 5 natural log of y. The second one, log base 4. I can factor out a 4, and I'm going to have x squared plus 2x plus 1. So I'm going to split up into log base 4 of 4 plus log base 4 of x squared plus 2x plus 1. So this is going to become 1 plus log base 4 of x plus 1 squared, which would be 2 log base 4 of x plus 1. All right, so now we're going to take something that's been expanded and condense it. So number 3, right here, we're going to say the natural log of x squared divided by y to the 4th, z to the 5th. The b part on that one, we're going to say log of x to the 12th, y to the 8th, because that 4, it's going to become an exponent, so we're going to multiply, over, this would be x to the 4th, and y to the 6th, because we're subtracting. So then I got to simplify it from there. I got to subtract exponents, exponent rules, x to the 8th, y to the 2nd. Number 4 right here, if I have 7, log base 7 of x to the 6th, we're going to rewrite it. 7 and log base 7 are inverse operations, so they cancel, so your answer is just x to the 6th. And then the b on number 4, I would have e to the 8th, natural log and common base e, they cancel their inverse operations, so e to the 8th, it's a minus x squared, so that's going to go on the bottom, and a plus y, so that's going to go on the top. And you're going to see those problems as well on the hogs. All right, last thing. I know I've thrown a lot at you. So now we're going to solve this without a calculator, because really we don't have base 4 and stuff like that on our calculator anyway. So this first one, I'm going to say log base 4. I got to think 4 to the what power gives me 64. Well, that would be 3. So it's a negative 3 because it's a fraction, so I'm going to write it as 4 to the negative 3rd. So 1 over 64 is 4 to the negative 3rd. Now when you do this, that's like saying negative 3 times log base 4 of 4, which is like saying negative 3 times 1, which is negative 3. The next one, it's log base 6 of 2 times 18, right? We can multiply, so it's log base 6 of 36. So I gotta think 6 to the what power gives me 36? Well, that would be 2. So that would be log base 6 of 6 to the 2nd, which would be 2 times log base 6 of 6, which is like saying 2 times 1, which is 2. Right? This would be written as natural log common base e to the 3rd raised to the 2nd, which would be natural log of e to the 6th. Natural log and e are inverse operations, so they just kind of cancel. So one way to think about it is like this, which is saying 6 times 1, which is 6. And then d, you're doing division, so 75 divided by 3, it's log base 5 of 25, which is like saying log base 5 of 5 to the 2nd. Which is like saying 2 times log base 5 of 5. Log base 5 of 5 is just 1. So I'd have 2 times 1, which is 2. And your homework's going to be Hawks Certified 5.4, but before you get into that, I want to talk about a few problems. This one you're just going to use a calculator on. So I would type in log of 214 and then natural log of that. So I'm going to say log 214, type it into your calculator. And then you're going to say natural log of your answer. And you should get 0.846. And then lastly, we're talking about concentrations. We're going to convert it. So there's a problem that shows up on the Hawks that I didn't really talk about a whole lot. If they give you a concentration problem, you're going to rewrite it as negative log of 5.99 times 10 to the negative fifth. So what that does is that says negative log of 5.99 plus the negative log of 10 to the negative third. All right, so I have negative log of 5.99 plus, this would be negative 3 times negative log base 10, which is like saying negative 3 times negative 1, which is like saying 3. Because log has a base of 10, right? So now I would type it in my calculator, negative log of 5.99, press enter, and I'm going to add 3 to my answer. So I should get 2.22, somewhere around there. All right. Those are just 2 problems that I saw that were on the Hawks, a little bit different than the lesson. So if you guys have any questions, make sure you reach out. I know that was a lot, and it's a long video, but that is all the properties and stuff that you're going to see.